Welcome to Next Gen Manufacturing. Today we're heading right into the workshop to talk about two fundamental ways to cut metal: conventional milling and climb milling. Now, these are basically two different philosophies of machining. And trust me, knowing which one to pick is the difference between a perfect part and a really expensive paperweight. All right, let's get into it.
So everything we're about to cover really boils down to this one simple question. As your cutter is spinning and moving into the metal, should its teeth be rotating with the direction the part is moving, or should they be spinning against it? This single choice has a massive ripple effect on pretty much everything: the finish of your part, how long your tools last, you name it.
Okay, so this relationship is the absolute key. Picture your milling cutter like a car tire, and the workpiece is the road. Is that tire spinning to pull the car along the road, biting into it and just rolling forward? Or is it spinning against the direction of travel, kind of scraping and scooping material out of the way? That's the core concept we're breaking down today.
First up, let's talk about the classic, the OG method: conventional milling. You'll also hear people call it up milling, and you gotta understand, for a very long time, this wasn't just one way to machine parts. For most people, it was the only way. So here's how it works. As the workpiece is fed into the cutter, the tool's cutting edges are spinning in the exact opposite direction. This creates this sort of upward, scooping motion. Each tooth of the cutter starts by making a chip that's basically zero thickness, paper thin, and then it gets thicker and thicker as it carves through the material.
And as this quote says, this was the common choice for a reason, and it wasn't just a habit or some old-school preference. For generations of machinists, using conventional milling was a hard and fast rule, and that rule existed because of the physical limits of the machines they were using. And that big limitation was a mechanical headache called backlash. In simple terms, think of it like a tiny bit of wiggle or looseness in the big screw that moves the machine's table. Well, the constant opposing pressure you get from conventional milling kept that screw tight and loaded, which stopped the tool from suddenly jumping forward and wrecking the part.
But, fixing that backlash problem created a whole host of others. Because that chip starts at zero, the tool actually begins the cut by just rubbing against the part. This generates a ton of heat that goes right into your workpiece, not into the chip where you want it. This can actually harden the metal as you cut it. It wears out your tools way faster. And that upward force it creates is constantly trying to pull your part right out of the vise. It works, for sure, but it can be a messy process.
All right, so now let's jump ahead to the modern default: climb milling, which is also known as down milling. And this method isn't just some alternative, it was a genuine leap forward in how efficiently and cleanly we can make parts. We are completely flipping the script here. With climb milling, the cutter rotates with the direction of the feed. The cutting tooth takes its biggest, meatiest bite right at the start of the cut, and then the chip thins out to zero as it leaves. The tool's essentially climbing over the workpiece, pulling itself along for the ride. So what changed? Why could we suddenly do this? Well, technology. This is really what next-gen manufacturing is all about. Modern CNC machines with things like super precise ball screws and clever software compensation basically eliminated the backlash problem. By solving that old mechanical issue, they opened the door for a much better way to cut metal. And the advantages are just huge. Because the cut starts thick, all the heat gets whisked away in the chip, which keeps your part cool and dimensionally stable. There's no rubbing, just a clean shearing action, so your tools last dramatically longer. The chips get thrown behind the cutter so they don't get cut again, giving you a beautiful surface finish. And maybe best of all, the cutting force is pushed down, helping to clamp the part more securely. It's a win, and a win. Okay, so we've looked at both approaches. Let's really put them side by side. A direct, head-to-head comparison to make the differences totally clear. I mean, just look down the columns here. This table tells the whole story, doesn't it? With climb milling, the heat goes where it's supposed to, into the chip. Tool wear is way lower. The chips are managed better. And the actual physics of the cut are helping you instead of fighting you. For just about every metric that matters for modern high-speed production, climb milling is the hands-down winner. So that's it then, right? Case closed. Just set climb milling as your default and never look back. But is it really that simple? Is there ever a time when the old way is actually the right way? And this right here is where we move beyond the basic rules and into what makes a true professional. Because there are a few very specific, very critical situations where the old school method doesn't just work, it absolutely rules. This is when a seasoned machinist makes the call to go conventional.
As the source material puts it perfectly, being a pro isn't just about knowing the new best practice. It's about knowing exactly when to break that rule. The real debate isn't about which one is better in a vacuum. It's about which one is the perfect tool for the specific job sitting on your machine.
So let's get specific. First, the obvious one. If you're on an older manual machine that has backlash, you have to use conventional. But the real pro move is for materials that have a hard outer skin. Think of a casting, a forging, or a case-hardened part. That scooping action of conventional milling lets the cutter get under that tough surface and lift it off, which protects the sharp, delicate edge of your tool. Trying to climb mill a surface like that would be like running your cutter straight into a brick wall. It would just destroy it.
So let's boil this all down into a quick mental checklist. Step 1, know your machine. Does it handle backlash? Yes or no? Step 2, look at your material. Is the surface super hard or rough? And step 3, make the call. Your default should be the speed and quality of climb milling, but always keep conventional milling in your back pocket as the expert solution for those key exceptions. You know, this whole evolution from conventional to climb milling was all about smarter machines solving an old physical problem. It just goes to show you that progress isn't always about brand new inventions. Sometimes it's about removing old limitations. And it really makes you wonder, as technology keeps accelerating in next-gen manufacturing, what long-held rule of thumb in the workshop is the next one to be completely overturned?